my computer.
I've mentioned that to IT also.
I'm sure you have. That's why they don't like you.
So, okay, last time we did two sample but dependent t-test. Now, chicken weight was one example, and the other one
Which is sort of like disappointing because I thought it was
was alcohol, I believe. Was it alcohol?
I think so.
Okay, it doesn't matter. Now I'm going to scroll down and read and tell me which one is reasonable for us to do a two sample t-test. Good. We'll start um, with or at letter C. So there we have a bunch of data sets of all the data sets that you see. Which one would qualify for a two sample t-test, independent sample t-test? Read carefully. And then all the data sets that we see, cabinets will qualify. Now, is it going to be appropriate in when we do all the analysis? We don't know that yet. We have to do pictures and stuff. But cabinets, two suppliers, independent suppliers, that would qualify. Um, Censored entry age and survival time of patients with small cell lung cancer under two different treatments, so they are independent. That would qualify. Insurance injury ratings of Chevrolet vehicles for 1990 model and 1993 model, do we consider them to be independent? 1990, 1993. So you pick, which one should we do?
Either cabinets.
No, you can't do either or. One, pick one.
censored.
Censored? Okay, we'll go with the censored data.
For the Chevy one, it wouldn't matter that it's from the same make. It's from Chevy.
It is from the same Chevy vehicle,
Would that?
manufacturer, but just two different models. But your question is, will the make affect it?
Yeah.
Probably, but we are excluding that factor. I'm going with the idea of using two sample t-test based on just that information, right? Once I get into the data, things might differ, but it's a great question. If I bring in make of the car, a two sample t-test may not be a good one to use. ANOVA or something like that, something like that would be better. So we're going to use the censored data. Yes.
I have a question. Is the cabinets one, could that be similar to like repeated measures because you're doing like basically the measure being the estimate of the cost from one supplier and then another one, but on the same homes?
On 20 prospective homes, we don't know if they are the same home or not. Just 20 of them. But our objective is to compare the cost between supply 1 and supply 2. Again, my initial assessment based on reading the statement seems like for the cases cabinets, censored and Chevy, we can use the two sample t-tests, independent ones. But once I look at the data, we may have to change our minds, and that's where I'm going. Good so far?
Yeah.
What is the very first step in statistical analysis? Of course, you have to look at the data, right? Capital C. So we have treatment, entry age, and the last one is survival time. Survival time is measured in days. Now, how do I know experience? Do we see two groups? Yes, no, maybe. Treatment A,
Oh,
treatment B. And I have two different variables. One is age, the other is survival time. If you are a researcher, which one should you be focused on? Louder, please.
survival time.
Survival time. Now, age does matter, but for the sake of simplicity, I'm just going to stick with survival time. Treatment A. What I'm doing is I'm getting the sample for the first treatment, which is A. Repeat the same sample for the second treatment. Sample B. Thank you. Repeat B. Subset would simply mean I'm partitioning the data so that I get treatment A, treatment B separately.
Here's what your variable in there is. You have to add an X in here, then
Ah, thank you. Sense. Being someone who likes programming, I don't mind red errors. I don't freak out if I see an error. I actually find them to be interesting because it helps me learn more and how to fix. So it's lowercase d. So I'm going to change it to lowercase d. So if I look at the first variable that I created, I will see data from only the first group, which is treatment A. Yes? Likewise, if I did that, I will see information from only the second group. Good? And we already agreed that we want to use the survival time and not age. Now, if you are interested in comparing the average age of people in treatment A versus the average age of treatment B, you will do a separate test. I will start with survival, and then we will do another case with age. Go ahead, Phoebe.
Isn't the age just like random, like they're taking random cancer patients?
Yes.
So like, isn't the goal to like, to like see the survival time, not the age? Like,
Well-
why would you want to see the age if it's random?
Now, imagine that I do the analysis comparing survival times for the two treatments. Of course, that is going to go through peer review. One might ask, well, you came up with this conclusion. Did you check to see the ages were approximately the same, right? So that is the next question to answer, because you make a valid point in saying, well, different age groups, I want the average to be close to each other. I can't compare treatment A and treatment B if treatment B was given to people between age groups 18 and 30, and treatment A was between 50 and 70.
Yeah, okay.
Not good, right? We'll do that as a second part. So first goal is to compare survival times it is in days between two treatments or among two treatments, among the treatments. Okay, in terms of initial steps, going back to maybe the second week of classes, what are two important things that you should do the moment you get your hands on data and have a good look at the data? Normalize. Well, okay, prior to that, what is a way to get summary statistics?
Instagram, no,
That's for the picture. Either you could do 5-number summary or simply type summary. I'm going to use 5num. Survival time for the first treatment. So there was a time when I would directly print. These days it doesn't. So I'll put it for treatment A, print 5num. Okay. That is the 5-number summary. Do we know what the 5 numbers are? You should, I know. Louder.
I don't know the other two.
Minimum, maximum. So the minimum, 152. Maximum, 1980.
Well, that's the mean.
Median, not the mean, median, Q2, Q1, first quartile, second quartile. Good. If you are interested in getting other statistics, you can do summary. Oops. Either will work. But I personally like summary because it makes things easier for us. Yes, it tells you which is which. So this is for treatment B. I'll do them separately. So treatment A, things match up, minimum, first quartile, median, third quartile, maximum, and it also gives us the mean. Okay, since we are doing independent samples, we need to find the variance. So let's find the variance, have it saved. So I'm going to do SD for the first treatment survival times. If you square the standard deviation, you get the variance. So variance for the first treatment or first group. Standard deviation is 456. I didn't square it. Bad man. Now, you shouldn't freak out, oh my, that the standard deviation is too big. The values that we have in the data are pretty large. We are measuring it in days. Will it change the conclusion in any way? No, because we are standardizing things when we find the test statistic. But some people would like to reduce the range. There are multiple other reasons, but we're not going to do that. It hurts me to copy paste. I don't copy paste, I just type them out, but I'm going to do copy paste so that we save time. No. Well, sucks because variance has the letter A in it. But case sensitive, I'll just go ahead and change it. B. B. Good. What we did for treatment A, we are going to repeat for treatment B. And let's see what the summary statistics tell us. Thank you. So the first output that you see there is for treatment A, the second one for treatment B. Our goal is to compare averages, yes. So mean, a question to ask. If you are a researcher who is researching these two treatments, what would your goal be in terms of survival time? What is the reasonable question that you would ask in terms of the averages? So you want to see if the survival time of one sample is greater than the other. Yes, it is treatment A's average survival time greater than treatment B's average survival time. By the looks of the statistics, 729.5, 546.5. They are, in fact, larger, but can I just stop there? No, that will defeat the purpose of statistics because we have to account for, starts with the letter V, variance. Maybe?
Okay, so there's 3 means. There's like,
The first number is a 5, put where the 1 is, it's the 5, it's just the null one. The second one is the summary.
So that is the summary, yes, for treatment A. That's just the 5-number summary. So that one and this one are one and the same.
why are they so different?
What do you mean?
Like, it's like 623. Oh, wait. Why is that one saying 1008?
It does, there is not, oh. 1003.
And then it says 766.
So when 5-number summary is calculated, the way it computes what odds is different from how the summary command is going to do it. So I would rely on this. For an exam, this is what I'm going to do. Not that.
Okay.
All I'm saying is you can use either, but 5-number summary does rounding, and it does a bunch of internal things. So I will rely on summary.
So we're comparing the 766.1 and the 546.5.
546. So we're going to compare for the one I just highlighted to this, the means. So 766.1 to 546.5. Okay, we know our research question, our objective, or the hypothesis. The average survival time of treatment A is, you can tell me, no. What is our hypothesis? For treatment A is greater than treatment B. Good. So that is our hypothesis. We did our initial summary statistics. Now time for a picture. You can either use a box plot, or you can use histograms, or you could use both. Entirely up to you. Well, I'm going to show you both, but it's going to depend on my mood. Yeah. So I will. So those are the two treatments. Of course, when I write an article where I'm going to publish this stuff, I'm not going to put a copy plot like this, right? I have class. So I'm going to make this pretty, make it decorative and all that. I'm not going to do it. So by the looks of it, it looks like treatment A's average is higher than treatment B. However, we've got outliers, we've got variability. Which one has greater variability? A has greater variability than B. What made you come to that conclusion, Phoebe?
There's more like of the dotted line, it's like longer.
More like the dotted line spread. It's wide. Okay, so treatment A has greater variability than treatment B. That is the first conclusion from again.
Weird.
You have to make it pretty. There are ways.
Yeah, not feel.
Exactly. Good. Another type of visualization is to use a histogram, which we did. With one sample, I put a question on the exam with a histogram. So let's see what the histograms look like. See, you saw that coming. So I'm going to compare the survival times for treatment A and treatment B using a histogram this time. Let's see what it looks like. Getting a warning. It's not degree, it's angle. giving us the finger.
Yes.
Okay.
Is that just treatment? Oh, yeah.
So right now, I only see treatment B. I don't see treatment A, right? Because they are on different scales. So I am going to look at the minimum value for treatment A and the maximum value in treatment A. So if I compare the minimums, I should start somewhere at 80 and maybe in 2000. So going to adjust the scale.
I have to put that C in front.
That's how you define less. Beyond the scope of this class, I won't get into it. Mm.
Oh, no, where is it?
Strange.
Like, I can make
Ah.
an argument, I don't think I would add.
Add equals true. I'm missing that. Okay. So it looks like the blue one is treatment A. The one in tomato is treatment B. You look at it, do you think that they are the same? Are they different?
You can't really
Go
see
ahead.
it.
You
Like,
really
no.
can't see it with the histogram, too much overlap.
Oh, I have a question.
Yes.
Can you make the tomato one like sheer so you can see transparency?
Of course.
Wow, okay, R knows everything.
All right. Since you asked,
Let's see.
$255, $99, $71. Okay.
I already forgot what it was. Are you done?
All set.
Ooh.
So now you can see that there is an overlap, correct? This is the overlap that I was talking about last time. So we looked at the summary statistics. It looks like treatment A is doing better than treatment B. Then we obtained a picture. Seems like there is a lot of overlap.
Wait, can you go back to that code really quick for the moment?
That one,
Yeah.
I can look into it. Talk to me after class. Or you can fix it as I go along. Sure. This is a histogram. Nikki was busy with her phone at this moment. Asked me last time, what type of a curve or should we expect? I drew a nice curve last time, and I said, in practice, you're not going to get a curve that is that nice. Rather, it's going to be squiggly. So I'm going to show you that squiggly curve. So I'm getting the density curve for the first one. density curve for the second treatment. Jeez. And I'm going to plot them together. So plot, going to be royal, but royal blue. Sadly,
OMG, DJ's favorite color.
and second, turquoise. That is not teal. Sadly, there isn't a teal option in on, but I can create the color though. Maybe next time I will. So I've created the two densities, Quigley curve. Why not?
Because you don't have an equal sign and you didn't do the line density.
What else? Is that
The
it?
line density in your A is density.
Okay.
Ooh, that's cute.
Okay, squiggly curve. So the one in turquoise, not teal, and the one in blue. Blue is treatment A, turquoise treatment B. Again, I'm not going to spend time on making this pretty. It's going to take work. On an exam, I'll make it prettier for you. But here, the curve is going up and then it's turning around and coming down. Even before we start the test and verify our hypothesis, just as a guess, do you think let me backtrack a bit. We agreed that we need a two independent sample t-test. Yes? Check. Is it valid? Is it appropriate to use that test? By looking at this picture. Yes or no? You should give your reasoning. Just, think about it and you tell me. We are going to do a two sample t-test, but for now, I'm looking at the pictures. Do you think that even though we have two independent samples, that a t-test is a reasonable thing to do for this data?
Yes,
Why, Phoebe?
because there's overlap.
Oh, is that one? Okay. So Phoebe says, yes, because there's overlap. Well, the overlap is actually the purpose for doing any test, right? You
Yeah.
want to know if things are similar or different. But should we do an independent sample,
No.
two sample t-test? Do we agree with Phoebe? Disagree with Phoebe? I'll give you a hint. Go back to last lecture. What is the very first thing that we should do when we have a test? We have make sure the data is normally distributed. One of the assumptions, if that is violated, your test conclusion is wrong. Look at the two samples. Do you believe that they are normally distributed? Absolutely not. There is a skew. Agree? Okay. What are two other ways to determine normality? We did this before the first exam. Ethan gave the answer already for one of the two approaches. which is Shapiro-Wilks. What is the other one? It was on the exam.
You can do it Instagram.
We already did that.
Oh, that's what they were talking about.
No, another one to check for normality.
Yeah.
I'll give you a hint. It has a diagonal line.
Line of us for first.
No.
Sorry.
Samantha? QQ plot. We need a QQ plot, and that is going to tell us whether a t-test that we do is appropriate. I'm going to do it regardless to demonstrate t-test, and there is that validation step. I will show validation to check for assumptions, and if they are violated, no matter what the test says, please don't put it in that article. Please don't say it to your supervisor if you want to keep your job, right? Because the decision that you make might cost lives, yes, money. So you've got to be responsible. You have to consider ethics. So next time I am going to